So, guys, let's see about this problem. Okay, so we are in this topic of composite bodies. Okay, so this is an example of a composite body problem. Let's see about which one is the composite body. Okay, so this bar, which I shown as yellow, okay, not in the best way, but I think you can get the picture. Okay, so this one is one bar, okay, one member or one link. This red one is another one, and this green one is another one. So you have a three body problem, okay? That's why it's called a composite body. And what they're asking you in the book is to get the forces located at CDB. I mean, in the whole bar, okay? Well, one thing that you already know is that somebody over here is pulling down from this corner with 240 pounds of force, okay? Now, let's go at B, and at B you will have the, and at B you have, I'm just changing the number over there, and what you will have over there is the a roller. So you have here a roller and you have here a pin, okay? So that's the post of the problem. That's what they are asking you to get here, the forces at CDP. And so this is the geometry that they're asking you to get. Okay, so let's go ahead and do equilibrium 2D. Okay, so equilibrium 2D for this thing, you will see that I don't care too much about the details. It's not that I'm doing this on purpose, but whoops. So like that, okay? So that's what I care about this body. Yeah, poorly done, but you get the picture. Okay, so here at A, I will have something going here, which is AY, and something going there because if you see the problem, or maybe you can see here that this A point is a pin support, okay? So AX and AY, and the external force, which is a 240 pounds over here. And then the roller, whoops, you have the roller over there. So it's feeling a normal due to this wall over there, which we're gonna call NB. Okay, so you have three unknowns, so you can actually solve this problem numerically. Okay, doesn't it suppose that composite bodies problem is when you cannot use equilibrium 2D for the global problem? So that's why you need to break apart into individual parts so that now you can solve it. Well, yes, that's one kind of problems, but there's another type of problem that they're asking you, okay, give me something about what this bar CDB, or maybe this AD here, or maybe this AC is feeling. So it's just another type of problem. Nonetheless, we are trying to break apart this body in order to study it individually and then get information out of that. Okay, so having said that, let's just go and do, okay, X. Let's just go at X. So X means forces at X equals to 0, and we'll put AX, okay, plus NB, yeah, equals to 0 if I'm not mistaken. Let's go with Y, and at Y I will have AY going up. That's it. Okay, so you should be equal to 240 because the minus 240 was in this place, but if I put in the right hand side of the equation I have 240. Okay, so right from the start I get one of those unknowns. And also let me just do moment regarding maybe A. Okay, so equals to 0. So what I have put over here are all the distances that you actually need, and therefore what I will get from here is, okay, so let's go with the MB. MB doesn't pass through A, therefore it produces a moment. It will try to turn it around like this. Hopefully you see it, because here is the line of action, okay? So it's passing below. So this is my lever arm, okay? That's what I need to walk from here to there, which according to this, it should be this distance 2, okay? That's what I'm using here, times 2, and it should be positive, okay? So according to my right-hand rule, I can get that one. And also the 240 pounds is producing moment. So let's just put 240 times the distance. So how much should I walk from here to there? So it seems that I need to walk from here to there to all this way, which is a 9. Okay, so, okay, 9, therefore now you equal to 0. Okay, but let's just see about the sign over here. And the sign will be, I don't know, maybe you see it, it's gonna be, try to move it around like this. Maybe you can see it because I don't wanna draw more stuff, but it's what it's trying to do, the 240 around A. So it's gonna be a minus. Therefore, let me just do this. So you're 1, therefore you need to be 120. And NB equals, I think I have it over here, is 1,080 pounds. Okay, so good. Now I have the normal at the wall. And let's just, with that knowledge, we can get AX. So AX should be minus 8,000 pounds. Okay. Oh, so it's minus. Yeah. So what does that mean? Well, it means that I put here AX as going to the right, but now it's actually going to the left. Oh, should I change it? Well, not right now. Okay, maybe later you need to put it in the right way, right as correct, but not as right or left. Okay. So far you already have that information for the supports. It's important whenever you can to get those supports. Some problems you won't be able to get it, but right now you can. Now let me do this here. I think I can do it around here without much problem. So whoops, I have this bar over here. Then I will have this guy over there. Well, you know, this is so okay. So let's just try to do it in the right way. You know, oops, I'm just wasting your time a little bit. That's what I'm here for, to waste your time. Yeah. And then you will have this fella over here. Well, what are you doing? I'm breaking apart this composite body, okay? So maybe you see that this is point A and this is point C, okay? Yeah, I see that. And then what? Now I'm gonna do free body diagrams for all of them and then get the CDB for this one. This is CDB, so C, and there here is D, and here it's B. Yeah, it's B over there, okay? Say, yeah, so what? Well, this is what I'm doing. This is the way to analyze this stuff individually. So let me just put some hints so that we know what we're doing. So A, this guy doesn't have a name, this point, but here you have D, okay? Now, this is my way to solve this stuff. What I'm gonna do is to put what I already know with what I don't know, and then use the equilibrium equations and try to solve everything, not just for this CDB bar, for everyone, okay? Well, that's why these things are kind of long problems, but nonetheless, they can be done, okay? So let me just put this unknown, oops, AY and AX, and I will put here what I already know, which is a pin support, 1,080, which is AX, is actually this one, okay? Well, so I'm gonna put it in the right way. And then AY, it's going up, that's 240. That's 240. Now, sorry about the source of confusion because you may think that this AY and this AX, you already got them over here and you would be wrong. What I got over here is what is happening in the pin support, okay? So this is just thinking globally what is happening at the wall here. But what I'm trying to know here is that maybe this point, this joint A over here, maybe because of this bar here, maybe it's trying to be pulled up and B try to be pulled to the right, okay? So this is because of the other bar, okay? That's what I'm putting over here. These reactions that I don't know yet are due to the bar and these ones are due to the wall. It's kind of a little bit of confusing at first, but maybe you get the picture. What I'm having here, if this AC was somehow alone, just by itself, therefore, just with the wall information, which is AY and AX, I'm done, okay? But no, this thing is coupled, this thing is actually coupled to the another bar, which is the bar AD. Therefore, I need to take that into consideration. And the problem will tell me if I'm right or wrong by doing that assumption. Well, okay. Now let's just put for C. For C, I will have this thing that I don't know because it's connected here. Here I have a joint, here I have a joint, and that's it. I don't have a joint over here and I have a joint over there. So whatever you want, you have joints, you wanna put reactions. So I'm gonna put this reaction as CY going up and here as CX. I actually don't know if these guys are really going to the right or up, but this is what I am assuming, okay? Okay, so now for that one, I'm gonna write the equation. So for x, I will write x, okay? I will write what I know and what I don't know. Let me just put cx plus ax, okay? And this thing should be minus oh my God, 1080. So I'm gonna put it in the other way around. Okay, so X. Now let's just go with Y. For Y, I have that CY is going up plus AY is going up. And I have also that this thing, I have a minus 240 because it was up in this part of the equation, but I'm going to put a negative in the other part of the equation, the other side of the equation. Now, um, let's just put what should I put over here? Let me just put, if I one moment, regarding C equals to 0. Let's see what happens. So for C, let's just take that into consideration. AY and AX. Okay, these guys will appear. Okay, so AY. AY will produce a moment around like this. Okay, so it will be a minus. Okay, times how much? Well, how much should I walk from here to there? Well, it says that this is the walking 3. Okay, so 3. Now, what about AX? Well, also AX will produce a moment regarding C. So AX times the distance, which is this height, and all that height is actually 4. Okay, so 4. And this thing should be negative as well. Fine. Let's just go with the 1080. Oh my God, this is a horrible equation. Yeah, I know that. And I will put, I will put this 180, 1080 times how much? Times the same thing, which is 4. Okay, now this thing is positive. And also I will get what? What I will get? I will get, what I will get for this, which one is the other? Okay, the 240. Oh my God, the 240 times a distance, which is from here to there. It's actually 3. Okay, so I'm gonna have that one. Equals to 0, and this thing should be negative. Okay, I can get along with this one. Okay, but I just want to show you that I just chose MC because I just wanted some of the points and be done with the problem. But maybe you see that I will get into this later. Okay, I can get into this one, but maybe if I can think about it a little bit, this is a 2D think a line of thought. Okay, so if I'm doing 2D, maybe this point C wasn't the best point because I have a lot of information regarding A, and that's why all of these guys appear in this equation. So maybe if I had done regarding A, okay, the moment regarding A, I will get into a easier way to solve it because I will have Cx times 4 positive, okay, I'm just taking into account this guy, plus Cy, just take into account that guy, equals to 0. So I think for our purposes, it's better to choose point A instead of point C. So when you're doing a problem in the test or whatever, so you just want to finish up as fast as possible. But if you dedicate a little bit of time in order to know which one would be a better point so that you cannot waste too much time working on that one, it will give you the same result, okay? But the idea is to save you some time if you can. So I'm gonna take this one. I just wanna show you that if I pick, it's not the wrong point, but I picked not the best choice for a point in order to write this equation of moment, okay? That's what I wanted to show. Okay, fine. Let's just move on to another way. Hey, are you going to solve it? No, I'm not going to solve it because first of all, I cannot. I have 1 unknown, 2 unknowns, 3 unknowns, oops, and 4 unknowns. I cannot solve this guy right away. Okay, but maybe you can get, yeah, maybe I can get something, but that's not the thing here. The thing is just to leave this thing expressed and be done with it for now. Now, let's just go with this one. I have A and D. D is easy. So what I'm gonna put, I haven't written D over here. So what I'm gonna put over here is dy, and I'm gonna put dx. Okay, yeah, sure. So now what? Now for A, I'm gonna do something that it's maybe weird for you, but that's how I solve it, okay? this is what I'm gonna do. I'm gonna think by something, this AY and this AX is not the same one as the thing that this bar is feeling. What? Well, what I mean is that maybe at this point A, this bar is feeling some AY and AX, okay, as a reaction, fine. And maybe because I have two bars, whoops, pinned to the wall. So maybe I'm thinking the wall can do something of its own in order to pull or to push more. So what I'm going to do is just make a possibility, okay? This possibility means that I can, let me just put it one more. I'm gonna think that maybe this AY is not the same one as the AY that I have put over here, okay? Maybe, because maybe the wall is doing something and the problem will tell me, buddy, you're just doing stupid stuff. Well, okay, so I'm gonna let the problem tell me that, okay? But what I'm doing is open the possibility that this reaction here at A for this bar is not the same one as this one over here. This is not a very typical problem. When you see problems on the net or in books, most of the times you don't have two bars coupled together in just one of them, unless you study trusses, okay? But in this type of problems, which is a composite body, it's not that common to have that, okay? So for example, at D, just have one bar and another bar going in. For here, you have just the roller, okay? So for here, for C, you have one bar linked, AC linked to CDB, okay? But here you have AC and AD linked with the wall. So maybe that's a source of confusion. So what I'm trying to do is give the problem the possibility that this AY and this AX is not the same one as these ones. That's why I named them A prime, okay? AY prime and AX prime. And if I'm wrong, the problem will tell me. Now, for dx and dy, there's no source of confusion. There's just one joint over there, one bar lapping into another one. Now, let's just go with this C point. This C point, I'm sorry. Let me just do the equation for this one. So I'm going to put x. What I'm going to put is minus ax prime, okay, plus dx equals to 0, okay, no problem there. Y, it's going to be minus ay, and plus dy equals to 0. And therefore, moment regarding, let's say, A prime equals to 0. So what I will get is dy times a distance, which in this case, let me just see how much is from here to there. I think it's a 6. So dy 6, which is a positive, and dx is also positive. Dx times the thing going down, which from here I can see that I need to go down 4. Okay, so 4, now you're equal to 0. Okay, now from here I can get that 3 dy. I'm just trying to put in as low numbers as possible to be more manageable, plus 2 dx equals to 0. So there goes my moment equation. Okay, so what can I write from here? Maybe I can do it, okay? So maybe I can do it. So x means that ax prime should be equals to the x, yeah. And ay prime should be equals to dy. So far I'm not doing anything. I'm not going to win a Nobel Prize out of it. But what I'm trying to assume is that, okay, so I have these equations over here in a more manageable form. Okay, so what? Maybe you wonder, why did I put them backwards? Because I'm doing the same rule as the typical rule. The typical rule means that if this body is feeling that it's being pulled up and pulled down and pulled to the right, therefore this bar maybe is feeling that it's being pulled, going backwards, okay? So it means that the point of view for this AD bar is different than the point of view of this AC bar. So this thing feels a push, okay? So this thing over here needs to be a push to, okay, but in the other way around. So it's just like a point of view perspective, okay. So this thing is going up, okay. So and now this guy is going down. And that's the way that you solve this stuff without worrying too much about the signs. Well, if you don't believe me, let's just wait to see what happens. Now let's just go to the last one, which is our interest, because actually they are asking you to get that one. Whoops, CDB. So let's just put here, since I already put C over here, I need to put them backwards because of the same rules that I was trying to clumsily explain. Okay, so here I have CX. And here I already have put D, so I'm gonna put it backwards, so dy, and then let me just put it here, dx. And for B, I haven't put B, but I already know what's happening over at B. What is happening over at B? Well, I have a roller, and I already know that this thing is 1080, and don't forget about your 240-pound force, okay? So that's what you have over there. And let's just see what would I put for x. So for x, I will have minus cx minus dx and plus 1080. And that's it. And this thing should be equal to 0. Good. Yeah, I'm right. Therefore, I can write, let me just save some time with this, equals to this, 1080, which is, I think it's more clear. Well, let's just go with y. Now for y, what I will put for y is, what would I put for y? Well, minus cy minus dy. This thing is going down, which is minus 240 equals to 0. Therefore, maybe you see that this thing, yeah, I'm gonna actually leave it like that. Okay, cy dy. Well, maybe I can change. Yeah, let me just change maybe something. Let me just do the cy plus dy plus 240 equals to 0. Well, it actually is not very important, but I want to somehow manage easier this, because I can get into complications when the numerical part comes in. Now, moment regarding, let's just do C. Okay, so C. If you do moment regarding C, let's see what happens. So dy will produce a moment, okay, and it will produce a negative moment. So I need to walk a distance which is from C to D, which is actually 3. Okay, so 3. Let's see about dx. No, dx will pass through C, so it doesn't produce moment. What about 240? Well, 240 does. So 240 times a distance, which is 3 and 3, 6. Okay, so 6. And this thing is also negative. I just put it really over there. Hopefully you see this minus over there. Let's just talk about the 1080. So the 1080 will also produce a moment, and I need to walk up, but just 2, okay? From C to I need to walk up just 2, and I will get a 2 over there. So this thing is actually minus. Oh my God, all of them are minus. Well, yeah, so sorry about that. Now what I'm trying to do is to, let's just divide this thing by 3. So you're 1, therefore you're 2, and you are 360. And now that I have that, no, I cannot do more things. So I'm just gonna put it like this. But if you see, I can already have one of them numerically, dy. So I'm gonna pass dy over here. So dy equals to whatever has been left in the left side, okay? Which is minus 240 times 2, which is minus 480, and minus 720, which is this part. Therefore, I already have one of those, which is minus 1,200 pounds. You know, this is pounds. Well, okay, now let's see. What about the sign? What does this mean? Well, the sign means that dy was put in the wrong way. That's what it tells me. So it should be up? Yeah, it should be up for this CDB point of view. It should be up. Oh, so here it's gonna be down. You're right. It's gonna be down here. Oh, so okay, but don't worry. Don't worry about trying to explain all of that. You just work with that. Since you already put them backwards, so you're not going to have any problems with the sign. Okay, so let's just do it. Now that we have that thing, let me just see if I can get more stuff out of this juice, okay? Because I already have this part of the juice, dy. Let me see which one of them helps me out. Well, from here I also can write that ay equals to minus 1200. Yeah, minus 1200. Oh, okay, so you already have one of them. Now from here, I can also use this one, okay, and say that, let me just see if I can do it now. I'm gonna just do it, oops, over here. And 3 minus 1200, 3 times minus 1200 plus 2 dx should be equals to 0. So I divide everything by 2, you're 1. Therefore, you are minus 600. That means that dx should be equal to, this thing is 1800, but it passed to the other way as positive, plus 1800. Well, okay, we are solving the puzzle. And also we are actually getting things that we are care about because they act on the bar CDB that we are caring about. So we have that information there, fine. Well, let's see what else can we get from here. Okay, so from here, I forgot about this part. CY plus DY plus 240. Okay, from here, I'm gonna get here. CY minus 1200. I need to respect this sign, okay? Not just in this set of equations, but in all of the equations, minus 1200 plus 240 equals to 0. Therefore, from here, I will have that CY equals to plus 960 pounds, okay? So the puzzle is beginning to uncover itself. So CY plus 960. Let's see what else. Maybe you can help me out at home doing this stuff, but I can go and use this one over here, okay? So I'm gonna use that one, and that means that I will get, maybe, you see that 4cx plus the 960 positive times 3 equals to 0. So if I do that, I was just want to show you how could I get that thing, but okay. So if I do that, I'm just thinking the way that I can, maybe I can, yeah, I think I can do it. So you are 2, therefore you are 480. Hopefully my arithmetics are right, because otherwise I'm doing myself a ridicule over here. Well, okay, I think that's right. Therefore, I can use 1, and therefore you are 240. Okay, therefore CX is gonna be minus 720. Oops, okay, minus 720. And also CX appears here. If I already have CX, this one, therefore I can write over here, dx equals to 1080. This was minus, okay? So this is a minus. I should put minus here, but I'm gonna put it as plus over there. So plus 720. Therefore, the x, oh, I think I got it over here. Also, I'm just going around in stuff, getting the same thing over again. Well, this is not such a bad thing to happen, because I'm wasting time, but I'm actually checking that these numbers are correct. So let's just put in, so I do not embarrass myself anymore. So, oh, we don't know actually. So dy, I already have it. Dx, have it, I already have it. The 10, yeah, I have it. 240, got it. Cy and cx, cy and cx. So I already finished the problem, because I already know whatever is happening over here. But I'm that ambitious. So boom, boom, you already have it. I don't have these guys, or do I have them? Yeah, I have them, because I already have AY. And AX comes from this equation. So from here, I can put that AX prime equals to this plus 1800. So I also have this stuff. And so here comes the proof of fire, to know that if this AY and X are the same ones, that this bar is filling A prime X and A prime Y. Well, okay, so let's just check it. Since this thing is hiding the stuff, I'm gonna put it over there. So CY, I already have it, so I'm gonna get over there. From this Y, I'm gonna get that, okay, let's just put it, plus 960, this is CY, plus AY equals to minus 240. So the AY should be equals to, this thing is gonna pass as negative, okay? It's gonna pass negative, therefore I will get 1200, which is a 1200 that I got over here. Oh, this is not a generalization of this stuff, but maybe you can assume that whatever is happening over here, it should be happen the same thing here. This is what we did. This is what we did in trusses, okay? But now I was just, a little bit nervous because the wall was doing something there too. So maybe it didn't pull the same way that here it pulls. So, I just wanted to check that. So maybe it was just not the it was maybe not the most professional way to do it, but since we are just discussing problems and exploring ways to solve them, it's not a bad thing to happen. Therefore, you already have this thing, which is the same one as this one, okay? So you're fine. Now let's just go with this one. So I already have Cx, which is minus 720. So I'm gonna put it over here for x. For x, what I have over here is that x equals to 1080. This guy was minus, right? So it passes as plus 720. Therefore, AX equals to, oh my God, let's see if this thing is 1800. Well, it is. So it gave me the same thing as this one. Therefore, you're set. You're set to what? Well, I just can do this. I just can actually do it. In order to summarize the problem, this is what I'm gonna do. I'm gonna put this thing here. Thank you. We're already done, okay? So let me just do it. Whoops, big whoops, whoops. This is the one that we were interested in, but you can get it for the other one, and they should be in equilibrium too. You have the normal. Remember the normal, the NB? Well, it was 1080. Remember the external force, it was 240. Remember that there was a D over there? Yeah, I remember that. And we had dx and dy. Well, hopefully you can go back and see that 1200 was going that way and 1800 was going that way. What I'm putting over here is putting, okay, so let's just, if I'm gonna do a finish, I wanna do it right. So 1800, okay? So you can go back and see what it was dx and dy for all of them. And I have put them now in the right way, okay? In the correct way. Since I already know this thing was minus or plus from the very beginning that I have put them, assuming that they were going in some directions. Now for Cx and Cy, what I have over here is that this guy is 720 and this thing over here is 960. Check it with the signs, and the signs will tell you in the problem if you have put them in the drawing right or wrong. Okay, that's the only thing that the minus will tell you, if you put them in the drawing right or wrong. Okay, so maybe well, we can do it. Let's just go ahead and do it. So at X, I have the 720 plus, the minus 1800, this one, and the plus 1080, and this thing should be equals to 0. I think it's 0, so you can check it out. Let's go see about Y. For the Y part, I have a minus 960, I have a plus 1200, and I have a minus 240 equals to 0, and you can check that out that this thing is correct. Okay, so whoops, you got that right. Okay, guys, if you don't understand something what I have done and you want me to do some more problems, you can put it in the comment section. I'm not doing a promotion of this stuff, but just want you to be as close as possible or as interactive as possible with this, with the way we are working. Okay, so see you guys.